Day 844, 63 through 73 odd. And we learned last time how to invert a matrix. Now, sometimes matrices are not invertible. If you get down, at some point, if you end up with a row of all zeros, that means that the matrix is non-invertible, which means two of the equations are essentially identical, or the third one is the sum of the other two, or something happened that made one of the rows all zero, which essentially means you're missing some information. In order to be invertible, a matrix has to be square. Okay? And we've learned how to solve matrices using reduced row echelon form on our calculator. We know how to do that by hand. There's another method to solving systems of equations using matrices, and it's called matrix algebra. So also, and this really isn't too bad. You are going to have to invert matrices, though. Take a look at 64. First off, does 64 have one solution? How do we know? The second equation is not a scalar multiple of the first. Now, with three equations, it gets a little bit more complicated because if two equations are identical, then that would create no solutions or infinite solutions. But if one equation is the sum of the other two, then that would also create no solutions. So we've taken this in a matrix 2, -3, 12, 1, 1, 1, and we've solved it that way. Okay? We're going to turn it into a different sort of matrix today. We're going to turn it into a 2 by 2. Oops, don't ask me what I was doing. A 2 by 2, and we're going to multiply it by a variable matrix that ends up being 2 by 1. And that will give us an answer that is how big? A 2 by 1 matrix that will give us the solutions. Okay? So the coefficients of the equation are the 2 by 2 matrix. The variable matrix will be the variables x and y. And then the answer matrix will just tell us what x equals and what y equals. So it's going to look like this. 2, -3, 1, 1. That's our 2 by 2. And then our variables are x and y. And then these are going to be the answers. This is going to be the x answer, and this is going to be the y answer. So before I do that, let me show you how to do matrix algebra. So we're going to take matrix A, which is 2 by 2. We're going to multiply it by matrix X, which is a 2 by 1. And then our solution matrix is going to be a 2 by 1. Okay, so I'm going to say A times X equals the solution. All right, well, how do we solve for X? We would like to divide by A, but there's no such thing as matrix division. It doesn't exist. So what we end up doing is we multiply by the inverse. And the A inverse times A is going to be 1. Well, it's actually I2, which is 1, times X equals A inverse times the solutions. So if I take A inverse and multiply it by those numbers on the other side of the equation, that will tell me what X and Y equal. So if I go back here, oops, I erased it, sorry. So over here I have 12 and 1. If I multiply by A inverse, then these cancel. So the answer to this system is just A inverse times 12, 1. That is the solution. So all I need to do is find out what A inverse is. So I take 2, 3, 1, 1, and then I put the identity 1, 0, 0, 1. And what would my first step be? I want this to be a 1. What's the best way to do that? Switch 1 and 2. Switch rows 1 and 2. So 1, 1, 0, 1. That's my first row. Now, I want this number also to be a 0. So I'm going to take this row, times it by -2. So -2, -2, 0, -2. And then I'm going to add these together. So we get 0, 1, 1, -2. Now I want that to be a 0. How do I accomplish that? So take the first row and subtract the second row. So the second row is going to remain 0, 1, 1, -2. And then the first row will be the first one minus the second. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1 is -1. And 1 minus -2 is 3. This is A inverse. If I take A inverse and I multiply it by the solution matrix, I should get X and Y. Now this is a 2 by 2, and this is a 2 by 1. You can't really mess it up. If you try to multiply it the wrong way, it's not going to work. So you have to do A inverse times the solution matrix. This won't work because they're the wrong size. So I'm going to take this, 12, 1, and that will create a matrix that is a 2 by 1. So that's -12 plus 3, or sorry, -12 plus 3 is -9, and then 12 minus 2 is 10. So 9, 10 is the solution. And this is actually what your calculator does. It doesn't do row echelon form the way that you do, where you switch rows, and that just takes way too much time. All it does is invert the first part of the matrix and multiply it by the answers, and that will give you the solution. Okay, do you want to see another one? Let's do... Let's do 72. It is. It's just a 0. All right, 72. So I need to invert 1, 0, 1, 1, 1, -1, 2, 1, -1. And then my solutions, well, I guess the equals on the other side are 3, -3, and -5. All right. So I attach I3. And then I do reduced row echelon form. First row is good. So to clear out this number, I need to do first one minus second one. And then to clear out this one, I'm going to multiply the top one by -2. So 1, 0, 1, 1, 0, 0. First minus second. So 1 minus 1 is 0. 0 minus 1 is -1. 1 minus -1 is 2. 1 minus 0 is 1. 0 minus 1 is -1 and 0. And I'm going to go ahead and change the signs on those. Okay, now I need to times the top by -2. So that'd be -2, 0, -2, -2, 0, 0. That turns into a 0. This turns into a 1. -3, -2, 0, and 1. Okay, I have a 1 in the 2, 2 place. So now I need to get rid of this 1. I'm going to do the second one minus the third one. So 1, 0, 1, 1, 0, 0. Second row remains unchanged. And then, so we'll do second minus third. So that's a 0. 1 minus 1 is 0. 2 minus negative 3 is 1. 1 minus negative 2 is 1. 1 minus 0 is 1. And 0 minus 1 is negative 1. All right. Now I just need to clear out this and this. So I'll times the bottom by negative 2. That will give me negative 2, negative 2, negative 2, negative 2. And for the top one, I'll times the bottom row by negative 1. So negative 1, negative 1, negative 1, negative 1. Top row becomes 1, 0, 0, 0, negative 1, negative 1. Did I do that right? The last one, okay, like that? Is that better? Okay, second row, 0, 1, 0, negative 3, negative 1. That should be a plus 2, right? And then the bottom row is 0, 0, 1, 1, 1, negative 1. So this is my inverse. So all you have to do to find the solution is take that and multiply it by this set here. So you'll do matrix multiplication. This will be your X answer, your Y answer, and your Z answer. Okay. Now, if you're inverting and you get down here and you get 0, 0, 0, that means that the square matrix is not invertible, which tells us that the original equation is either infinite solutions or no solutions. It just depends on what those answers are on the right side. Okay? So I think you only have, what, like 6 problems to do? Good luck.